again. So at the moment, the thread pool has 31 threads, I think. See 29 here. And 0, that's 30. No, 30 threads in, probably. Yeah, probably. I have 32 threads, one for the main thread, one for IO, so ePOL, and then 30 for the task, at most. It is not nice that we have 30 threads that crash on a third. So, I guess step 1, let's reduce the number of threads so much that we find, if at all, it starts working again, and then determine, yeah, that limit. Maybe it works if I reduce this to only a single thread. Maybe not, I don't know. Now I have to find out how to reduce the number of threads. I don't know. Hi, Yu Trong Kwang. I'm going to reduce the threads. How do we do that? Well, probably something with AI threadpool. What about the constructor? Number of threads, there we go. And indeed, concurrency -2. So I just pass the number of threads, and then we have that many. Nth prime. Now let's try 2 threads. I mean, that should still go wrong, I would say. So it could, of course, by coincidence, go right. But almost immediately fails for both threads. Well, that's interesting. That makes it more likely that it is something trivial, I would say. This assert is saying the following. I just reset a bit in the sieve. And of course, that bit should correspond with an integer that is divisible by that prime. That's why we reset the bit. So I calculate what the integer is that it's not a prime. It's exactly not a prime. Should rename this. But the integer that this bit corresponds to, and then we make sure that it is divisible by the current prime. The current prime is 19, which is the second prime that we will discover. 17 being the first prime. The rest is already known at the beginning. Clearly, that's not a little off. That looks totally random. It was calculated from debug row. That's a very large row and a column. So it's a random row and column. So if we just reset the bits at this column and that row, Then we did reset, then we said, well, this integer is not a prime. Postponing, yeah, I just started, coincidentally. The word index is very large, 380,967. We have 30,030 bits in one row, and we have this many rows, so we have this many bits in total, which should be about 1 billion, because 10 to the power 9, and that's what it is. Because, well, that's how large the sieve should be. We're trying to find all primes up till 1 billion. So the number of rows is obviously correct. Yeah, I guess we'll never know, because the first row with prime multiple is row 2. Well, that makes sense. And then the call word offset is woo, big, big, big. W, the word index was this. So the first one was apparently correct then. It's kind of really weird, man. Oh, I think I understand it. I think the reason here is simply that we continued while a thread was still running. So one thread was wiping for prime 17. And then the main thread continued and overrode this value with 19. So suddenly it's 19, and yeah, then the assert fails. Which means that if this modulo 17 equals 0, then we have a pretty big chance that is the reason. Yeah, okay. So the reason is that the prime was overridden with 19 while we were still wiping 17. Well, that can only have one reason, and that is that we didn't sleep long enough. Maybe we should start with that point then. Hey, looks it. Yeah, this won't cut it. We just have to wait here until all the tasks that we just started finished. Actually, you have to wait there, if you ask me. This loop is 90 large, so we come here 90 times. And then for each of those 90 times, you add a task to the threadpool queue. This task, this lambda here, and so on. And then at the end of that loop, that means after adding 90 tasks, we have to wait until all the tasks finished. Because if we continue, then yeah, we are just going to mess with the same stuff that is now the other threads are already writing to. We don't want it. How do you wait for n tasks to be finished? Okay, Hugh Trong Kwang. I don't know how to pronounce the Hugh. My first thought yesterday was, while I was thinking about it, is a semaphore. But the semaphore, you can picture a semaphore as a basket with a limited number of balls in it, and a long queue of thread people. And they are standing in front of the basket, and each person that comes to or at the basket, they take one ball out of it, and then they immediately continue. And they do a task, and well, when they are finished, they return the ball to the basket. So if there is 30 balls in the basket and the row is 90 long, then only the first 30 people will take a ball out of it, and then the 31st will look in the basket and see no ball. And then they wait until someone throws a ball in the basket again. And then they pick that one and they continue walking. So that's how a semaphore works. And then you're sure that there is at most 30 people that are doing that task, because you have only 30 balls. In this case, however, we want to start 30 tasks and then wait until they're all done. So in terms of that basket, we would have someone waiting at the basket, looking inside, but not taking a ball out of it, and then waiting until the basket is completely full with all 30 balls again. That has nothing to do with the semaphore. So, no semaphore. What it does have to do with is a conditioned variable. The thread must wait until a certain condition has been fulfilled. The condition being that all tasks finished. Well, okay, we can. How do we determine that? Well, we just, I think, use an atomic and set the atomic to 90, and then whenever a task finishes, it decrements the atomic, and once it gets to 0, then all tasks are done. Let's add the atomic. I'm thinking about, I can add a variable. That would be yet another variable. Can I just abuse a variable here? A variable that we already have anyway. Probably not. No, we can't. Okay, standard atomic. No, just an int. Let's initialize this thing with, I'm going to use braces for some reason. Let's initialize it with 90, which actually is the repeat. I think it is in primes. Yeah, that's a global in the namespace primes. Divided by, let's see word bits. Well, this is already inside, we are already inside namespace primes, so you can just do this. Compression repeat is the number of times that, of the number of integers that are not divisible by the first compression primes that have well, random looking gaps between them until it starts repeating. So this is 5760, and then we start over and have the exact same gaps as we had before. In other words, it's the number of bits in a row, in one row. So divided by word bits is the number of words in a row. Don't we have that somewhere already? Now I think about it. Must have been calculated in this way. Yeah, words per row. We already have that. Might as well use that, although it's just compile time. So we're going to start a task for each word in a row. We start them here, and then when a thread finishes, it must decrement that value. I don't think, it probably doesn't even have to be an atomic, because we need a mutex. Condition variable uses a mutex, unless I am going to spin lock here. I don't feel much like spin logging, I must say. That's really 100% CPU of one of the cores. Exclusively we're waiting. Locking and unlocking a mutex takes, yeah, maybe even 100 microseconds or something like that. It's 15 microseconds per system call. Going to sleep and waking up takes a lot of time. Let's say we literally go to sleep here and then we wake up again, and we only do the once per prime then. So the number of primes is we find under a billion, we find this number of primes. So if that takes 100 microseconds, then is this many times 100 microseconds. Hello. That is eternity. Do I see that wrong? Will be this many milliseconds? This many seconds? It's more than an hour. What? Oh no. Hey Matthias. Man, that's a lot of primes. 51 million. If I want this to be, say, 50 milliseconds in total, I really don't want to spend any time on it. Then we have a nanosecond per prime. That's never going to give a speed up then. Never. Okay, maybe a spin loop is the best attempt here. Interesting. I did not realize that this was so. I really don't get it. Is that really? My God. Okay, so, yeah, let's do that. So I'm just making a spin lock here that waits until that atomic is 0. So while I think what I also want is that all sieves have already been written to. So we write to sieve, and then we change the task, and then we read that the task was changed, and then the sieve must already have been written to. In other words, it's an acquire-release relationship that will be sufficient. But yeah, this must be a read modify write. Well, I cannot not remember how to do a read modify write with a certain memory order. Is that not just like add or something? Atomic int. Yeah, fetch, that's the one. Fetch add. Fetch add what you want to add, and then the memory order. Bad memory. What is it say about the memory orders? Yeah. I think a release is enough. Let's see if that works. CPU relax is just to stop the memory bus or the, what is it, the CPU bus or one of those buses to completely block. So you just do without it, then you just do so many reads that other CPUs won't even be able to write to it anymore. And this kind of means just let other cores do the thing first if they want to, which is obviously logical because we just read it and it was unequal 0, so there's no reason to read it again until some other CPU has accessed that same memory. Possibly decremented it, like here. Damn it, you need a reference now to the running task atomic. I don't want to add another thing to the lambda, so I'll just add it here. It's not depending on prime, so I think I can do it outside. Just add it here. Initialize. When you tell the compiler outside the constructor that it has to be initialized with that. Obviously, this is going to be initialized at the moment the constructor is being called. Or maybe we should put it here anyway. Okay, let's put it here. And these things then have an underscore for some reason. I'll do it like that, I guess. Yeah, well, you can choose, because I use parentheses there instead of braces. Maybe I should use that here as well, or maybe I should use parentheses of braces up there. Let's go for the minimum number of changes. It's turning that into parentheses. No, yeah. Data is const. It's not allowed anymore because we are totally changing it. Wasn't also not really necessary because I had all these things already marked const here. Apparently CPU relax is not in namespace utils. Don't know why. Okay, so what happens if we run this? I have the feeling we're not getting speed up. Oh, we're using 2 threads. It's 2 times faster. No, it's not. The overhead. Unbelievable. Or things are just blocking, of course. Let's have a look at what everything is doing. That one is definitely... Oh, these are not doing anything. And this one is waiting. So you could have waited a long time here. $180. Okay, someone tell me 90 plus 90 is 180. And therefore I should have done fetch sub. I'm so stupid, it's unbelievable. Start at 90 and then I add 90. Yeah, hello. Fetch sub is probably a little bit smaller. Now we actually go to 0. And it finishes. Wow, it finished correctly. With 2 threads. This is entirely in debug mode. That used to take 10 seconds. So now I'm curious what happens if I run it like this. That's already faster than 10 seconds. It felt like faster. Wow! Wow! It does give a speed up. Oh, that's really, really nice. In the meantime, I really had not expected that anymore. Let's add the stopwatch as well, because I'm only speeding up now the first loop. So that's something we definitely can see then. Error benchmark include their optimization. Okay, then I have to turn on optimization. Well, that's print environment. Yeah, just go for it. Reload environment. Configure. Cycles was not defined. Cycles. You view stopwatch. Oh wait, it's just a comment. No. Ridiculous. The definition of the declaration or definition of cycles just vanished. What? Next thing, we don't have a delta either. When did that happen? Delta. Nope, no delta either. So bright. Can I do a search in here? Control F or something? Nope. Search. Cycles. So not working. Nobody gets it. Why is search not working? Ridiculous. It is highlighted. Can I do search now? Yeah. Also not defined. And that was here. Search. Okay, it was already broken before we moved it to this repository. So before it was in utils, I think then. Maybe I can find it back there. I don't get it. I mean, it worked before. How can I not find code back that? No way it doesn't work here. pissed off. It's one of these moments where everything points to that this can never have worked at all. I'm pretty sure I got my code from here, from the example code. But it does not define cycles. Or delta. Where did I copy the code from then? Now, and then we have something that is as fast as it was before. If you look at the timings though, I don't see how that adds up to 1.25. No, it did get slightly faster. It seems to be pretty linear though. I think before it was half a second and now it's 1/3 of a second. That would be completely corresponding to the number of threads that we use. Let's just go all out to, no, let's just double it first. Theoretically, I have the feeling it should work, aka not go wrong. Oh, no, it doesn't go any faster than 0.3 seconds. Doesn't matter how many threads you throw at it. That is disappointing. So I guess the 0.3 seconds is the main thread, and the rest of the threads are now way under that point. But then what happens if we increase the number of... Let's try just 10 times as much. If you do one thread and 10 times as much, I cannot remember what the speed was then. I think it was 14 seconds, more even. It was more than 10 times slower. Oh, that is not bad then. This is not bad at all. So before this, oh, actually this is slower. Yeah, okay, yeah, 14 seconds. That's what I said. So this is correct. I hope, I think, must be. It is. No, it just works. Very good. Very, very, very good. And then if I use two threads at a time, so we have 8.8 seconds, which is, well, I don't know where the other 6 seconds went. Oh, I think I do. Yeah, that is in this. That is this loop, reading out the next prime. So this is just filling the sieve, and then we spend 6 seconds reading out the next prime, doing all of this. That takes a lot of time as well, of course. And that won't speed up at all. Because, well, not using any threads there. Maybe I should add a stopwatch around this as well and print how long that takes. So do that. Stopwatch. Where's my stopwatch defined? Here. Stopwatch. And then stopwatch start. And CPU is any. Uh-oh. And then just as you think it works, oh yeah, we're hanging on initializing the stopwatch maybe. Let's try it again. No deal. What the hell's going on? Can't run GDP because we don't have debug symbols. Dang. No, it doesn't hang, of course. I have two stopwatches on the same CPU. It does not finish, but I don't think we got this far last time, or did we? Now, what the fuck, man? Things worked perfectly before I added stopwatch. Then, so why would it now suddenly no longer work? So without the stopwatch, let's comment it out. Pretty sure that this is what I added and then it stopped working. I didn't change anything else. But I did change something, of course. This takes too long. Let's go back to the release again. CWD. What? Yep. No, it reproduced 3 times. Let's include this here. reproduce still. Let's create a new stopwatch. Wow, okay. Creating a stopwatch twice apparently makes things stop working. What the hell? What if we run this one on CPU number 0? I think that is the problem, yeah. It picks any CPU, but what it does, I think, is while stopwatch is running, it restricts the program to a single CPU, which is kind of stupid if you actually, or maybe just the current thread. So the main thread is already restricted to a certain CPU, and then we start a new stopwatch, and that tries to do the same thing again, and that just doesn't work. So what I probably need to do is create my stopwatch after we return from generate. Then this one creates a stopwatch and destroys it again. And then we create our own stopwatch. So I'm gonna put this below here. Now it should work, I have the feeling, hopefully. Yep, that was it. Well, that's really strange, but okay. And now we can print it here. How long that takes. So I cannot have the same thread construct two stopwatches, apparently. Didn't know that. So now we have 5.8 plus 4 is 9.8. Still a lot of... Oh, there's a 1.2 here as well. If I add those things, so you know, 5.8, 7 plus 4 is 11. Oh, reasonable. And that's with 2 threads. So we double the number of threads, then hardly faster. 4.4 instead of 5.8. And the rest is the same. It's kind of strange. And we go full out, 30 threads. .6. It's even slower. Why is that so slow? Yeah, there's not much of an improvement. Let me try 10 times more even. That's 100 billion. It's using 100% CPU now. So it's definitely doing something. Still using 100%. If this is going to take longer than 10 times longer, take a 47 seconds for row 0. That would be impossible. Oh, looks like it. Oh, there we are. 86. It is slower. More than 10 times slower. Yeah, now it's back to 1 core. So from 1.3 seconds to 21. Oh, couldn't. Interesting. Oh, interesting. So it seems that I've run into codem before when I tried up till 1 trillion. And that also took a long time, so maybe it's just core dumping while calling next prime. Apparently, I think the sieving was done. Yeah, definitely. Yes. So we could debug this by writing the whole sieve to disk. Maybe, and then loading it from disk in debug mode. Or or putting next prime in a different file and then just compiling that the sieving stuff in with optimization. But yeah, no, not very optimal. I could spend another 2 minutes waiting for it while not calling this. CNT. No idea why this would cordum. I would say if it cordums in here, then it must be inside an explorer. Maybe index overflows. That seems impossible in 64. Well, these maybe. This one would be impossible because compression repeat is just small. Could that overflow? The number of primes divided by the compression repeat larger than 2 to the power 31. And then we will get a very negative row, which then would access wrong memory. Let's see if the row still fits in an int in this case. So index is going to be equal to that can hardly be with 100 billion. No way. So this can contain 2 billion. And this is way smaller than 100 billion. And then we divide it by 5,760. No way. Cannot overflow. sieve index. Yeah, but an integer is not signed. Okay, what type would it be? It is unsigned. That is signed, I mean. Integer type, or sorry. It is unsigned. This type would be int plus word call integer times sieve rows, which is also integer. So this is multiplication is an integer, so the result would be a large integer. Yeah, okay. So that would be this one then. And then if not 0 less than or equal z, I just said that it was unsigned. If not z is less than no, the size of the sieve in words. The word sieve size times words per row, sieve rows times words per row. Okay, 2 minutes. In 2 minutes we will know more. I'm going to turn on the lights because, yeah, we're big. What? What? 2 minutes still didn't pass. How about I'm going to make myself a cup of hot chocolate? Well, you have to do that more often, doing long calculations on my computer. Get to do all kinds of stuff. Oh God, I never knew I could do so many things in 2 minutes. I can even go to the toilet. Oh, it's already at 86 seconds. I'll be right back. Toilet. Bathroom, I mean. I'm so disappointed. Well, I'm so disappointed. Why is this not telling me? Well, we have this extra output. That's about it. It's crashing somewhere here, but not on my test. Yeah, I guess I'll just have to put this in a separate file, which is then not compiled with optimization. So I can debug it. Really strange. Can't be negative, can it? Sometimes you're procrastinating or, well, doing nothing because you know what has to be done, but you don't want to. So I'm literally doing nothing now. And the reason is that I just, compiling a certain part of my code with optimization and another part without. Blah. So instead I'm just thinking of another better way, or if I can get around it. Oh well. Mm-hmm. 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 What do you mean primes has not been declared? Oh, it's namespace fast primes. Yep. Fast primes. Undefined reference to. Oh, that's just another thing. Otkin. Yep. Maybe it was not necessary. Fast primes, let's see, XX. Bottom, delete that, paste that here, try this again. Yeah, but it was necessary. Oh, this is also Otkin 3. Makes sense. Fast prime 6. And when is fast prime 6 using this? Huh? What? It's like completely not using it. It's totally not using it. Oh, it's linking with, and then it doesn't work. Okay, yeah. God. That's what I mean. It's just a pain, this. Pain. That doesn't work. Probably this one. The rest works. Okay. Configure. Make CTZ. Did you mean what does CTZ? What is CTZ not known? Oh, sorry. I moved it. I moved the bloody function. Zero column to prime. Oh boy, I need that. Well, I can do that with an external. It's inlined here. Now, as an inline, I can do that. But then we need a reference, or an external reference, I think, to row 0. Or this won't work. It's defined as a cons expression. I don't care. Well. Is const expression part of the part of the name mangling or not? Just what happens if we do this? Probably doesn't compile. Uninitialized, yeah, not good. Wait a minute, I should do extern const expression. Oh, declaration of const expression variable is not a definition. Okay, and now the trick where we hope that it is not part of the mangling. Only find reference to false primes row 0. I think it is part of the mangling because it starts talking Chinese to me. Yeah, those are problematic things. You just have to copy that too. Make a copy of it, as it were. Row 0, row 0. What is this all using? Hopefully nothing. Oh, small primes. Yeah, I think I have small primes. I'm just copying all of this. Paste that as well here. And then let's rename them because, yeah. X. Otherwise I have two definitions. Links. We have another 2 minutes pause or break, is the right word. So to figure out what happens now. Oh, wait a minute. Well, yeah, I want to see if it works. It doesn't. Oh, it does. Actually, it does. 1 second. Oh, yay. Yeah, it does work. Okay, so now for compiling that one file with, well, this is no debugging whatsoever. And now I want to compile this file with, oh, go to executable. No, just this file. The big trick, cd that directory, object dir, and then we do compile till there with a -g, and then we continue that file, and after that we also have to link. So I'm doing this. It looks like linking, but there is an O3. You see, make a little bit crazy in the head. Oh, what the hell? I'm not doing that. Skipping. And then everything else. I guess that should work. Oh, and then we get that. And then we get that. Well, okay, we can do that. We can just remove it. Benchmark. To comment out this because you can't do that. Stopwatch. No stopwatch. 0 and if. Now I change just that file, so I can do this again. And then we can run it. just can run it. It's amazing. Okay, and then let's see if I indeed can debug it. So we now do break main, run, list, next, next. Just step through it. And then we can do step inside next param. I think it works. Okay, so let's edit this again, and now we go to our pulse core dumping with 100 billion. That's gonna take another, well, 80 something seconds. Let's call it 2 minutes. So now I can drink my hot chocolate. It's still too hot, but I'm gonna drink it anyway. It just means that you will have to listen to me slurping, because it is too hot. Abhimanyu Sharma, hello. Guisanda, hello. I stopped working on the engine because I don't know, too difficult. I haven't given up, but I started doing other things, and I don't want to go back. Yes. It already printed 86 seconds. I hope it core dumps again. Let it be a reproducible core dump. Wow, it did. It was very nice, but very nice. I'm happy with the core dump. And it is that first one. Wow, I had not expected that. Index is extremely negative. What happened here? I think the initial value is minus something, minus compression, which is 6, so minus 6. And then we increment it until it becomes 0. And then we're updating index, and that updating went wrong. Aha! So this is where it went wrong. Maybe I should not have left the debugger. So now I want to know what row is. No, that's not true. I want to know what the row is at this moment. So we just need an assert here. Row is an int. Compression repeat is an int, I guess. Yep. And column is an int. Int times int plus int is an int. And index is not. So I guess this overflows. And I'm not sure if that makes sense. Okay, how many rows should I have? Well, sieve rows. Maybe I should have sprint that out. Sorry, I'm gonna do another 2-minute thing. I just want to assert here and then I can print everything. Because actually my life exists of a chain of things that I do. Now normally one thing leads to another and then I start that. And those things can be very long chains. So if then at some point I finish something, then I should go back to the previous thing. But if the previous thing is, in the meantime, years in the past, then sometimes I'm just like, nah. I might as well never go back. It's something from the past. Now you're telling me that it did not assert. What is that? What? I'm an idiot. I'm the usual idiot. I did run make. Did not assert. Looks pretty negative to me. There's a minus sign here. It did not overflow here, because then it would have been all F's. Apparently you did also not get assigned that negative number here, because, well, that never asserted. If I set a breakpoint 125, I get a breakpoint 126. Oh, so my assert is non-existent. What? Yeah, that's it. We don't have an assert. I left that in. Why did I do that? Now we're at it. Why not enable CW debug. Is that not going to work? I think that requires some other define as well. And a linkage with it, which I'm also not doing. Get undefined references. Yeah, we don't really need it, I guess. I also have to go cook dinner. Today I went to some, well, they called it a workshop. I didn't know that. So I thought it was something free that you just could go to. It was about a discussion about philosophy, some subjects. So I just went there and we did get coffee or tea at the beginning. And then everyone sat down. And then they wanted to begin, and then the last moment some other person came in, and then they got confused because there were no chairs anymore. And well, shortly afterwards, I did find out that I had just come and I had not paid. I didn't reserve, and I had not paid. I didn't know that you had to pay. But okay, I was allowed to stay. I didn't have to pay. And I supposedly I said a few intelligent things, so they liked that I was there in the end. Oh no, I'm getting tired of this. Still no assert. Now I'm getting seriously pissed off. Just every time it takes 2 minutes. How is this possible that I still don't have an assert? Oh! I'm so stupid. But at least I realize now what it is. Yeah, okay. So I really need to do the debugging thing here, which I really don't know because it's a lot. So I need to copy that first from an actual debug compile. No, that should be it. That is because yeah, CWDS is also compiled release mode now. Can we work around that by removing the whole debugging stuff, which I don't really need anyway? I mean, I want to assert, but I don't need a debug output. And now it should work. If now it still not works, then I'm going to eat dinner. Make dinner, eat dinner. Probably going to do that anyway. No. That's why I was procrastinating this. It's just a pain. So I have to go to the kitchen to make dinner. And what I'm feeling now is that I would like to be able to rotate my chair 90 degrees. And then just have, the kitchen here. So I could just start cooking. You know, so cook here on my right a little bit. And then while watching the monitor, maybe you can type and stir at the same time. This whole getting up thing and leaving your computer, it's not my thing. I don't like it. At least while I'm sitting here, I don't like it. Usually when I go out do stuff, then I'm happy. Just wherever I am, I'm just interacting with people or doing some stuff. But all the while that I'm sitting here, we have an assert. I just don't want to get up and go eat, for example. Shocking. No, it's not negative. You have to do it again. I'm sorry. No, we didn't. We didn't. Yeah, we did. Because it's an assert. Where's my assert? It doesn't seem to speed up a lot though. I mean, apart from this crash, and I want it to work until till 10 to the power 12. Insist. So yeah, this I have to fix this. But the threading, it got a little bit faster with 2 threads, 3 threads also, but then 4 and more threads didn't even make that much difference. But okay, we can think about how to fix it. In fact, I was already thinking about it. I think that maybe what I should do is make these tasks such that they do they just go to the next column as long as there is a next column without returning to the thread pool. That doesn't make no sense. It should not be that much overhead returning to the thread pool and being started again. Definitely should not be much overhead. But still, might as well, you know, might as well do more columns if there is still another column. And also the main thread can participate maybe instead of doing a spin lock. I could have it do the slowest column. By the time then that finished, it's spin locking, looping shorter. I think we got it. This is where we assigned that value. And now the question is, why was it assigned? Row is big. Column is not that big. Compression repeat is 5760. Now you're going to tell me that that row times that number is larger than fits in an integer? No. Yeah. I guess. No, it fits in an integer. But then you add column. And then it becomes negative. That is completely true. Yeah. Definitely get an overflow there. Now, how many rows is normal here? Equals sieve rows. 333. Wow, more. Oh, we have 3.33 million rows. Yeah, I guess that makes sense. It should be 100, 1, 2, 3, 1, 2, 3, 1, 2, 3. Divided by 303, sorry, 0, 0, 0, 0, 3, 0. Plus 1. Close enough. Yeah, because it's rounded up. What I'm actually calculating is okay. Row times compression repeat can overflow. Yeah. Maybe I should not do that until I test it. If it now just works. Ah, fuck. Or not. I'll just suffer the consequences. I'm going to assume that it is fixed now. But if it isn't, then I'll have to do all of this again, which will take me 1 minute. Git status, git diff, everything. I commented that one out, yep. And another 2 minutes. I thought it printed more debug output actually in the beginning. We're not seeing anything now. Why not? Well, the debug output of the stopwatch seems to be turned off. But I'm going to let it run. I'm going to let it run 1 more minute. Oh, there it is. Starting reading out sieve. That took, how long was that? It's not crashing. Two and a half minutes. It claims that it around 34 minutes in user time. So 2 minutes is fast for all primes till 100 billion. Oh, maybe it is. No. Well, kind of is. Let's first check if this is correct. 455. Something else. That looks correct. Well, at least I see a lot of nines. Yeah, 99,999,999,977. And that's that number. Therefore, it is successful. 100 billion. We already did successfully 500 billion. So we do 10 times more now, then we have a trillion. Then it's going to take, I don't know, I think a lot more time than this. But I'm not happy with not having my stopwatch output. What happened there? It's just a standard cout. Time spent calling? Okay. I guess I just turned it off then. Let's see. Primes.cxx and fast primes /that. I turned it off. Why? I'm going to cook and hope that it will finish quick for some reason. Meaning I'm going to run it for the full 1 billion. Trillion, I mean. Just 10 more. 12 zeros, that was my goal. When I see that working, then I can concentrate on the threading again to make it faster. Memory usage, more memory, more memory, more memory, more swap, more swap, more swap. A little bit more memory. Okay, it allocated everything. 10 seconds just allocating the memory. Can you imagine how much work it is? To sieve that all. Now it's using a 100% CPU, can't get around that. So all threads are doing something. That is a 30 threads. 30 threads that are doing something non-stop. And now it stops. What? Oh, it continues again. I have the feeling that this might finish within half an hour. And the number of time it spends on row 0, that might be quite fast, because that's with all the threads. That should be quite fast. Hopefully within 5 minutes. If it prints that it is finished with wiping row 0 within 5 minutes, then wow, yeah, then it's just very good. That would just be very good. So row 0 is more or less the first let's say 5,000 primes. And those are the small primes. And they take, well, then you need to toggle most bytes, most bits. So those are by far the bulk of the work. We're doing that with 30 threads now. And then after that, I still have to do, I think, 30 million rows. But those are just pretty large primes, and they fly through those rows. So it doesn't really matter that the number of rows is that much bigger then. It's more going to be something linear with a number of primes, which of course is also starting to get really big now. The die is just over 50 degrees Celsius. It's not hot. I could touch it. Okay, this is hot. Now it's 61.5 degrees. But just shortly. Strange. Can I move this thing? Oh no. Oh no. I tried to move it and it went away. Oh, there it is. No. Oh, it's hidden behind. There it is. That's what I was looking at. So I have 32 gigabytes memory. Usually it's like here-ish, and now it went all the way there. And a little bit of swap, which is also 32 gigabyte. So together, I think it uses, I would guess, 25 gigabytes for the allocation, and we can calculate what it really is. So it would be 100, well, I guess 1E12 plus 30029 divided by 30030. That's the number of rows times 5760 is the number of bits divided by 8. It's the number of bytes divided by, let's do 1024. So that's kilobytes divided by 1024, megabytes divided by 1024, gigabytes, 22 gigabytes, 22.3. That's how big the sieve is. I think we have passed the 5 minutes, unfortunately. It's taking pretty long for row 0. I am starting looking around though here. I don't see anyone. It's a bit scary. 7 users. Who hacked into my computer? Well, I'm just kidding, I guess. No, I think I logged in 7 different places. Probably consoles. You could say 7 consoles are open. What happens if I open another console? Eight users. Here, well, who am I? Carlo. Very schizophrenic thing here. Maybe it's not a good sign that it uses a little bit of swap. Every time it has to write to the swap. And that's going to be something extremely slow. No, I have no idea how long it takes. But I leave it running because I just want to get past the point that I know that it works till a trillion. So I'm going to cook while it runs. And I guess I should stop streaming then. I do have a good feeling about it this time. Without threading, I think it took 37 minutes actually, 47 maybe, before it crashed. So I really should finish in within half an hour. Should it? But then again, oh no, that was for 500 billion. So maybe twice as long then. But now we're doing with the threading stuff. I don't know, half an hour. Print something, damn it. Nope, I'm going to cook. Anyone voting for leaving the stream on? Or nobody staring at this line here, hoping that it's going to print something very quick. Give you 10 seconds to reply. Probably too short, considering everyone's having a huge like.